I was teaching some high school students matrix algebra and realized that they knew Cramer's rule but had no idea how to derive it. Cramer's rule is actually a very inefficient method for solving a system of linear equations. And the only thing interesting about it is its derivation. So to learn Cramer's rule without learning the underlying theory is, in my opinion, rather pointless. Now for some background. Gabriel Cramer lived in Geneva, Switzerland during the first half of the 1700s. He published his rule in 1750. That makes Cramer's rule 275 years old, and high school students are still learning it. In this video, I'll show you how to derive Cramer's rule. But before we do that, I need to show you two important properties of the determinant. The first property is that the determinant of a constant times any column is equal to that constant times the determinant. The second property is that you can multiply any column of a determinant by a constant and add it to any other column. Here, we multiplied the second column by k and added it to the first column. So now let's solve a system of three equations and three unknowns. The equations are in standard form. x1, x2, and x3 are the unknowns. The a's are the coefficients, and the b's are the right-hand sides. We can write this system of equations in matrix form. The coefficients form a 3 by 3 matrix, and the unknowns and the right-hand side are column vectors. For reference, let's put the original system of equations down here in the corner. Now consider the unknown x1 times the determinant of the coefficient matrix. We can bring the x1 inside the determinant to multiply the first column. You can see that the first column of the determinant now matches the first terms in the original system of equations. Now we multiply the second column of the determinant by x2 and add it to the first column. Finally, we multiply the third column of the determinant by x3 and add that to the first column. Now we can see that the first column of the determinant is just the left-hand side of the original system of equations. And we can replace the first column by the vector of right-hand sides. We can now solve the resulting equation for x1. Using similar operations on the second column, we can solve for x2. And by operating on the third column, we can solve for x3. And we have Cramer's rule. The unknowns for a 3 by 3 system can be found by computing 4 determinants. The determinant of the coefficient matrix is in the denominator and can't be 0. The other 3 determinants consist of the coefficient matrix with the first, second, or third columns replaced by the vector of the right-hand side. Although Cramer's rule is not very practical, we can still appreciate its elegance and beauty once we see how it can be derived by manipulating determinants. I'm Jeff Chasnov. As always, thanks for watching.